Assalamualaikum warahmatullahi taala wabarakatuh dan salam sejahtera. My name is Muhammad Khairul Anuar bin Sharif and I'm from Jabatan Kerja Raya Malaysia. I would like to present and share my PhD research of performance and parametric study of phase change material, solidification and melting in solar thermal evacuated tube. Outline of my presentation as shown in the slide. As an introduction of my research, solar thermal energy to heat domestic hot water is one numerous research area that have high potential for renewable energy source. This study to present the simulation of solar thermal evacuated tube system using phase change material. U-tube and concentric design flow were simulated with combined the effect of PCM tube design and system operating parameter on its thermal storage by using ANSYS version 17.2. Current studies take different design parameter into consideration. Many storage system geometries has been considered, such as vertical cylindrical container and multi-tubes array have been shown to be the best geometry for enhancing heat transfer due to large heat transfer surface area. This video is an overview of concept solar evacuated tube hot water system. This shows on how domestic hot water mechanism being heated by sunlight, which is the water temperature will increase from 27 degrees C up to 140 degrees C inside the closed loop piping. It will absorb the sunlight and the water is being heated inside the tank. In a normal condition, it is considered that to have a storage whereby it will be stored the hot water inside the storage tank. And there is another option that the water is being heated by solar evacuated tube, and then the hot water will be directly to be used. Methodology of the research is to develop the 3D simulation model and then to design and fabricate with integrated of solar collector with the phase change material. After that, we will evaluate experimentally the performance of the thermal energy storage, and lastly to analysis different missions such as duration of charging and discharging of cycle and also the thermal energy storage density. From this slide, there is a three type of thermal energy storage: sensible heat, latent heat and also thermochemical storage. My study focused latent heat energy storage, where the energy released or absorbed by a body of thermodynamic system during a constant temperature, processed with solid to liquid or vice versa of phase change material. The material with scientific name of RT82 kind of wax or lilin in bahasa with energy density of 176 kilojoule for each kilogram were used. This material with melting temperature at 82 degrees Celsius and also solidify at 78 degrees Celsius is suitable to combine as a thermal energy storage for evacuated tube, where inside the piping temperature can goes up to 140 degrees Celsius. For physical and numerical modeling in ANSYS simulation, assumption has been made to simplify the simulation as shown in the slide. I also showed the boundary condition in this slide. This slide showing the construction of evacuated tube system with thermal energy storage and experimental instrumentation at field. Experiments were conducted to validate the simulation result. The field instrument consists of trolley, come with the water tank, flow meter, variable speed drive pump, heat exchanger and also heater. The Keyence instrument with industrial monitor data logger were used for data recording. The experiment was set up following the ASHRAE standard on assessment of solar collector performance showing figure in this slide. Thermocouple were inserted at position as shown TC1, TC2 and TC3, and each duplicating the position of simulation for purpose of validation. As a result, from the graph comparison at TC1, highest temperature with normalized root mean square with difference of 3.03%. For result and discussion, which is the objective of my research to identify better design of thermal energy storage, parametric studies on design parameter of the solar evacuated, a minimum and maximum range of each parameter were predefined as per table 4.1. Parametric studies done using design of experiment or DOE method, central composite design CCD, and 9 design points were generated based on the minimum and maximum values of each design parameter. These 9 generated points are presented as per diagram in figure 4.1. The effect of length of PCM tube melting fraction. From the graph, the longer PCM tube length to achieve of T of 0.05, it is higher. This is mainly due to the increase of phase change material mass, which is directly proportional to the tube length. Total specific energy storage comparison for the tube length, the longer of PCM tube design, it have not only higher capacity to store more energy, but also it take longer duration to deplete its energy storage while maintaining high water outlet temperature. Okay. For the result and discussion, the effect of phase change material tube diameter to melting fraction, where PCM tube discharging thermal performance are highly detected by the mass of PCM. The results show that bigger storage diameter of 44.1 mm is the slowest reach to its full solidification state. This implied that the larger the diameter of the PCM tube is able to withstand longer duration to deplete its energy storage while still maintaining longer high water outlet temperature. As a result from the simulation, both parameters studied, PCM tube length and PCM tube diameter, are directly proportional to the discharging thermal performance of the PCM tube as a solar thermal energy storage. Thus, parametric sensitivity, or also known as impact factor, is studied to identify which one of these two parameters have the highest impact towards a better discharging thermal performance in the solar energy storage using PCM tube. For this slide, as shown in figure 4.12, from the simulation result on design optimization MOGA, it can be concluded that the effect of increase of storage diameter for optimal design is higher than you increase of storage length with percentage of 55.8% versus 44.2%, with about 12% more increase of stored energy. This figure showing the mass fraction contour for discharging process, where orange color indicate the PCM in liquid state. And as the time build up, the heat energy being transferred to water, the PCM is solidified and can be seen in its color change to blue. As a conclusion, by fulfill the predetermined optimization objective, an optimal design of latent heat thermal energy storage is proposed. The new design has improvement on the thermal performance of the collector tube with PCM energy storage. The largest contribution of this study is to provide basic input on the capability of solar energy collector tubes by integrating PCM phase change material as thermal energy storage. It can be used as a reference basis for the development and improvement of system or design for future researchers. With combining of renewable energy and thermal energy storage, there is a potential of increasing the efficiency of having cost-effective and sustainable energy producing mechanism. In terms of governmental policy, this effort could be very potential in being part of helping our government effort to combat climate change and become carbon neutral country by the year 2050, as mentioned by our Prime Minister in RMK 12 announcement. With this regard, more investment, the research and development should be considered by the government, as the technology can be found on the off-shelf, and the research could be concentrated on the material of latent heat energy storage. Thank you.